Okay, let's get started with today's lesson. Well, actually lab. And a couple things that we should look at first is where we are with the course right now. So let's take a look back here and take a look at our addendum. And this is the second part here. We're dealing with a temperature sensor, and the temperature sensor we're dealing with is a thermistor. And you're going to be putting the Grove shield on the Freedom K64 first. Then you're going to be connecting up the temperature sensor with that little 4-pin cable that came with it. You're going to connect it up to the temperature sensor. There's only one way to connect it, and then you're going to connect that up to the A0 connector on the Grove shield. Now also on the Grove shield, you're going to find a little slide switch, and it's either 5 volts or 3.3 volts. It's very important that you put it at 3.3 volts because the Freedom K64 works with 3.3 volts and ground. It does not work with 5 volts. Now the pot, which is the angle sensor or whatever they want to call it, you're going to again connect that up. You're going to plug in the little connector that came with it, and you're going to plug that into A1 on the Grove shield. So you'll see that there's A0, A1, A2, A3. So again, and there's only way to plug these in. So the temperature sensor goes into A0 and the 10K pot goes into A1. And there's a lot of stuff in here as far as that goes. But today, don't worry too much about the lab test, or lab quiz, the LAB5 quiz, because it's only worth 1% of your mark. And but there's a fair amount of stuff to go over with that. So let's take a look at LAB5. Now it goes over things such as class member functions and talks about the pot. And you can click on these and go through these. But when you start going through the actual questions on the test, it's going to ask you about thermistors and all this kind of stuff. So you should go over that in the first period. And I'm going to hopefully give you lots of time to do that. Now, when you procedure here, when you click on this link and import this into embed, compiler, and get it working, you're going to find that there are some errors. Now, the best way to find out the errors is this program that you have here is perfect. It works. But when you click on this link at the top, it's going to bring you in something that's not quite the same. There's some subtle differences, and you should be able to find out what those differences are and how to fix them. And it says in LAB5 quiz later, once you've done this, keep track of how many errors you had to correct. And these are going to be syntax errors, ones that will not allow the program to run if you don't correct them. And you're going to have to figure out how many of those you had to fix up to get working. And that's the first thing you're going to do. Now, in the second one, you're going to click on this link to bring in code that's almost identical to this, but there's going to be some subtle differences. And in this case, it says at the bottom, there are no syntax errors, which means your code will run, but it's not going to run properly. And you're going to have to make some error or corrections to these program statements to make sure that it runs properly. And again, this one here that you've got, that you're seeing coming up on the screen now, does work properly as long as you make sure that all the things that you put in here are the same, or all the things that are here are what you have when you bring it in. So you're going to have to change that. So things like how does it grab temperature and do all this kind of stuff. So again, how many lines of code had to be changed in this one? And you're going to see that when you first plug it in, you should see the temperature on your screen coming up around, I don't know, it depends on how hot your house is, but somewhere in the low to mid 20s would be typical in Celsius. And then it should print out the equivalent Fahrenheit. And you may have seen this before in your PRG 1 or 2, where it has 9.0 or 5.0 times the temperature plus 32 is how you convert from the Celsius that you've done the temperature for here and convert it to Fahrenheit. And that's why, and this put charge 0xF8 is a degree symbol. And that degree symbol will show up on your PuTTY screen as long as you've done that CP24 thing or whatever it is, there it is, CP437. As long as you've changed the PuTTY translation to CP437, you should actually see these degree symbols coming up when you get F8. So make sure you've done that. Now in this one, it shows you to actually take that same code and copy, get rid of the library that's there. You can clone it first, then get rid of the library and put the one that says classes there, and then export that to MCU Express. And when you first get it all set up and you get everything going, then when you start running it, it says to set a breakpoint right after it does a temperature reading, and it shows you all the stuff to do in this video to fix this around. And then you're going to actually take a temperature reading. You're going to hold your thumb on there, take a temperature reading and a resistance reading, and then keep holding your thumb on the little IC that's on your temperature sensor, and the temperature will increase, and then take the resistance reading and so on. And the resistance reading is going to be in kiloohms, okay? So if it says 0.99 something, that's 0.9 kiloohms. And so as you go through this, these are the things you're supposed to do. And then from these readings, as the temperature increases, as this temperature goes from here to here to here, does the resistance go up or does the resistance go down? And it says based on the type of thermistor, if it increases, that's a positive temperature coefficient. If the resistance decreases with increasing temperature, that's a negative temperature coefficient. Now, the first line of code gets a 16-bit unsigned number, and that's why it's got 65,536 here divided by whatever minus 1. Now, that's when you're using the U16 to give you a 16-bit unsigned. But if you just do voltage, you can see the U16 here. So this is going to give you a value between 0 and 65,535. Now, if you do float though, and instead, and you say float voltage 1, and you say input 1.read without the 16, it's going to return a number between 0 and 1.0. And the advantage of this is you can scale this up quite easily. For instance, if you are turning your pot or something from one to the other, you know the actual total voltage maximum is 3.3 on the Freedom K64. So by you get 0 all the way to 1, you can then multiply it by 3.3 and actually translate it into a real voltage between 0 and 3.3 volts by a simple multiplication. Now in part 5 here, it says in MCU Express, so add these two lines to the bottom of the while loop. And what you're going to see is it's going to actually have the value of the reading in kiloohms coming up. So as you hold your, and again, terminate the program, use the blue bug button to compile and download the new version, remove the breakpoint. So the other part of the stuff where it showed you in the video, you set up a breakpoint, so every time you ran it, it stops. You could take a nice reading, then you hit the run button again, and it stops again to take the next reading, and so on. You're going to take 3 readings from before, but in this case, you're going to remove the breakpoint and just let it run. And what you're going to see is as you hold your finger, you're going to see constantly updating on the PC screen under PuTTY. At this location here, you're going to see what the resistance is as the temperature is changing. So some of the things that you should with this, as the resistance and temperature being displayed, as the temperature increases, the resistance decreases. Does it? Yes or no? The thermistor used is a negative temperature coefficient. What does that mean? If the temperature increases, the resistance should decrease. That's a negative. A positive one, if the temperature increases, the resistance should increase. So that's a positive. So is it a negative temperature coefficient? And more to the point, when the temperature is 25 degrees Celsius, it showed in one of the videos that you should have watched, is the resistance approximately 100 k ohms. So can you check these off? And that's basically the lab today. So in the second period, what you're going to have, let's take a look back here under lab quizzes. So LAB5 quiz, as it shows here, is going to show, let's make that bigger so you can read it. So it's going to show up at 3:20. So what I would strongly suggest now, as it says at the start there, is get as much of this done as you can, because you're just going to be answering questions about this. And so if you got a lot of this done before the quiz shows up at 3:20, then it's going to be a very short period. If you don't, you know, and whatever, it could be a lot longer period. Now, the other thing that I should mention, which is kind of cool, is if we go back here and go to DF. Now, under DF, you're going to find under here video lectures. And for video lectures, not just week 6, which we're on today, and you should look through this. This is all the stuff on analog to digital, analog versus digital measurements. There's a whole bunch of stuff in here. But what I've also done, and I'm not quite finished yet, but I will be finished shortly, is there's video lectures also for next week if you want to get a little bit ahead. And the video lectures right now are on LCDs and stuff that we're going to do next week. And there's one extra thing I have to put in here yet is on interrupts, and this is all covered again under the new course addendum. And this is the second part here again, just take a look. So just to let you know here at the bottom, The interrupts that it's mentioning here this week, we're not going to do anything with those because we're going to be doing ticker, which is periodic interrupts here, as well as regular interrupts in the second week here, because the chapter quiz isn't going to be until next week anyway, and it's worth 2%. So by that time, interrupts and periodic interrupts will be covered, and it'll be in the video lectures for that particular week. So I've pretty much gone through everything, I hope. So my question is, at this point, let me just see if I can get this back up here. Do I have that screenshot? So my question, is there any questions before you guys get started, or are you in pretty good shape? As I said, the lab test is in the second period. Do as much as you can in the first. You shouldn't have too much trouble getting through this, but again, the stuff that's shown in LAB5 as code is perfect. So please compare your code that you import with the code that's in the lab to see where the differences are, and that will help you troubleshoot your code. Any questions before you get started? Okay, so I'll see you guys at 3:20. So in just under an hour, I'm going to tell you when the lab quiz is going to start, so please work ahead. And as I said, you're the only group, the DF, has got any of these video lectures for next week, but you do have video lectures for this week. So I'll talk to you guys again about 3:15, and we'll go over any problems that you got before your lab quiz, okay? I'm just going to shut off the video recording.